Good evening, ladies and gentlemen. Doug Gray here from D. Gray Drafting and Design. Tonight I would like to introduce you to our latest kit, the DC motor kit. Here's an assembled example. I'll run it now just to give you an idea. Then we'll take a quick tour of the motor. Self-starting. Self-starting, surprisingly powerful on 7.2 volts. Here's the motor itself. I'll just point out some of the parts. Up front we have a fan, blows air over the brushes and commutator. Here's our bearing housing with a deep groove ball bearing inside. Carbon graphite brushes, polycarbonate brush holders, brass terminals, terminal hardware. Commutator, the contacts on the commutator are made from brass pipe, or from copper pipe, pardon me. The armature has 3 coils. You get to wrap the coils with number 30 magnet wire. Stator frames with neodymium magnets. 8 magnets, 2 frames. Stainless steel shaft. And a 2-speed pulley on this end. On the base we have slots so that you can adjust the stator frames in and out. Same with the brushes. You can find the sweet spot on those brushes so that it makes good contact yet allows for maximum power. Let's have a look at the kit. This is the way the kit will come to you, nicely boxed. Sturdy box for shipping. Well packaged. Padding. And with the drawings lying flat, it's actual printed drawings, 14 pages. The kit comes with 2 bags. Bag 1 of 2, bag 2 of 2. 19 separate items. There's our fan, there's our bearing, our brush housings, there's our coil of number 30 magnet wire, there's a shim tool to help you set your motor up, bearing plinths, pulley, stator frame, armature core, the base, and there is the core for the commutator and the shaft. There's the copper pipe. You're going to be making the contacts for the commutator out of. I've provided 2. You only need 1 really, but I've provided 2. There's the carbon graphite brushes. the ball bearings, the brass stock to make the terminals for the brushes out of, all your nuts and bolts, and there's our 8 neodymium magnets. Crazy powerful. Tons of fun. The recommended voltage for the motor is from 6 to 12 volts. I'll run it again. I'll give it a little more juice just so that you can see. It's amazing how powerful the motor is. We take all these inanimate objects, apply a DC supply to them, and it magically springs to life. Guys, I just wanted to give you a quick review of the drawings here before we move on to running the motor again. Nomenclature, all the different parts of the motor labeled. Kit contents specifies here everything that you get in your kit. 19 separate items. Here it talks about the stator frames, how to set up your magnets, etc. Winding the armature, creating the contacts for the commutator, assembling the full armature, etc., etc., setting up the brush housings, final assembly, just to give you an idea of what's all involved. It can be done basically with just hand tools. You'll have to do some solder. You got to solder the magnet wire onto the commutators. Okay, we'll run it on 20 volts. Polarity is the right direction, so the fan is blowing over the brushes. Brushes are staying nice and cool. Lots of power there. That's 20 volts. It seems to work fine. I just specify 6 to 12 just in case. DC volts. There you have it, guys. Link in the description where you can go to my store and purchase one of these kits. Tons of fun. Build it with your kids, build it with your grandkids. Buy it for them as a science fair project. Get together with a younger person, show them all the skills of assembling something like this. Thanks for watching. Enjoy your shop time.